This is a very interesting FSM question where we need to build a FSM for a serial communication channel. So the question is as follows: in a serial communication channel which transmit blocks of ones and blocks of zeros, all blocks of ones are of odd length and all blocks of zeros are even length. The new data bit is presented at every clock period. Design a mealy state machine to detect an error in transmission, that is, the state machine would assert a signal error whenever blocks of ones are of even length and blocks of zeros are of odd length. So the correct transmission would be uh, the blocks of ones are of odd length and blocks of zeros are of even length. If any of this if both these conditions are not met, then it is wrong. Okay, and we need, if any of these conditions is not met, we need to assert the signal error, error signal high. Okay, now we are getting blocks of data. The data bit is not specified. Okay, and we also don't need that. Okay, so we are transmitting blocks of zeros and blocks of ones here of certain length. We need to build an FSM which detects a certain number, what number of zeros, is it odd number of zeros or even number of zeros, and the block of ones are of odd length or even length. Okay, and then assert the error signal accordingly. Now for building any FSM, the first step we do is build a base state or the okay. So this is the first step you need to do. Now the nomenclature of the state doesn't matter here, just name it anything, s0, s1, s2, and we need to just take care of its functionality. What does this state represent? Okay, so this state we would take, okay, we would take the blocks of zeros to be coming first and blocks of ones to be coming next. Okay, so when the reset button is pressed, the state the FSM is in the state S0, and it is expecting some inputs, blocks of zeros. Okay, so when no zero is there, then it is even zeros. Then when 10 comes, odd ones. When 20 comes, odd even zeros. When 3, odd zeros. Okay, so similarly, when we when we press the reset button, when no, it is expecting zeros, so it will naturally be in even zeros state. Once we get a zero here, we will go into state S1, which represents odd number of zeros. Okay, again we get a zero, then we move back to S0, which represents even number of zeros. Okay, so it is like this. Once it was expecting some input, it was at even zero state, it got 10, it moved to odd zero state, it got another zero, it moved to even zero state. If we get another zero, it will move back to odd zero state. So the odd zeros, detecting the number of zeros part is done. Now we need to detect the number of ones. Okay, so because now detecting the number of zeros is over, we would either end up in even zero state or odd zero state. Now we start receiving the blocks of ones. Okay, so for that we need to have two more states, one representing even number of ones and other representing odd number of ones. Okay, now I'll write it below. Okay, even number of ones, and this state represents odd number of ones. I'll name this S2, I'll name this S3. Okay, now from here, if we we are getting the first one, so it is odd number of ones. Okay, so from here, if we get 1, we will move to odd ones state, and from here, if we get another one, we would move to even one state. Okay, so I get 1, and then I get ones consecutively, and we shift between these two states, odd ones, even ones, odd zeros, even ones. Okay, so these states. Now if we were on the odd zeros side and then we got a 1, we would move to odd zeros state again. Okay, so then we would move to odd ones state again, and then this cycle continues. Now the error signal is asserted high. This is the FSM is complete right now. Okay, so we would test its functionality by giving some random inputs. Okay, so the error signal, the output is error signal, or the output is asserted high whenever the FSM is in either odd odd ones state, or even odd ones, yeah, odd zeros, or zeros and even ones is what we don't want. Okay, so if the FSM ends up in either of these state, even ones this state, or odd zeros or this state, so if the FSM ends up in any of these states, then the error signal should be asserted high. Okay, so this would come only when the data transmission is completed. So it is not mentioned in the question or itself, but if we think practically, we need to take a like start bit or stop bit. Okay, it is in communication protocols, they generally have a start bit and stop bit. So whenever this communication is stopped, and then we need to check if the FSM is in odd state, odd zeros and or even one state, S2 or S1. Okay, so end signal, end transmission signal, and S1 or end transmission signal or S2 would give us the error signal. So okay, so the error signal would be high when the transmission ends, the data transmission ends, and if it ends up at odd zeros, which is an error in the serial communication, or if it ends with S2, which is even number of ones, which is also a error in the communication. So this is the FSM for the above question.